thank you both. So now I would like to give the word to Christophe Lepage, who works in Montpellier in France at CIRAD, the French Agriculture Research and International Cooperation Organization, working for the sustainable development of tropical and Mediterranean regions. Christophe has extensive experience with designing and using interactive agent-based simulations and role-playing games. We are very happy that he had the time to join us today. So Christophe, now the floor is yours.
Thank you, Melania. It's also my pleasure to be here with you today. I was asked to talk about using data from participatory sessions in agent-based modeling. I wished I could propose you something more generic than just telling you about the processes that I participated in the past, but unfortunately, I did not find time to prepare something that would be more wider than my own experience. So I will tell you about two experiences I participated in the past. And maybe we can, from this presentation, we can start a discussion. I think that we have now quite a lot of material with other people using this kind of role-playing games approach or game-based approaches to co-design or to design agent-based models. But I think that maybe it's more interesting to envision a kind of collective work or collective effort to bring different kind of experiences together and to try to produce something more general. I have to apologize for maybe those of you who already heard about the experiences I will tell you today, because some of them are quite old now. My plan today is to talk about two experiences, and one is, I have some problem to move on my presentation. No, okay. By clicking, it seems to work. Okay. I'd like to talk about the self-core experience, which is now almost 20 years old, because it's a kind of seminal experience in the use of role-playing game in combination with agent-based simulation in Senegal. And I will also briefly talk about another experience in Thailand. I wanted to stress the importance of the preliminary phase in these participatory processes, because what is shown here in green in the bar corresponds to the collaborative design and use of models, role-playing games combined with ABMs. But I think that there is always a preliminary phase. We are talking about participatory modeling, and when we start to work with models, we already had a more or less long preliminary phase with interaction with local stakeholders. That is quite important. So in the two examples I will present today, you will see that in Senegal this phase was quite long, and the collaborative design and use of role-playing games and ABMs was quite short in time. While in Thailand, it's more or less the contrary, with a very long collaborative design and use and a set of role-playing games, actually, not only one, but a set of role-playing games, and a slow maturation evolution to the design of the agent-based model. But still, in Thailand, we had a very important preliminary phase. So I think maybe my message today would be to stress the importance of this preliminary phase and how this is compulsory to engage in the co-design of the models. So let me start with some reminders or a short introduction of the self-core mass experience in Senegal. It's a project that was designed 20 years ago in Senegal, and it's on empowerment of a local decision-making process for land use management. It's a nice example of a combination between role-playing games and agent-based simulation. And I will tell you the methodological aspects related to this project. So it's a Senegal River Valley, which is a region that is widely altered by irrigation schemes and frequently affected by drought in West Africa. And in the Senegal River Valley, it's a a project that started and was my colleague Patrick Daquino was involved in this project for several years before we joined him, with the idea to use role-playing games and agent-based simulation as, let's say, an additional methods to bring some new insights in the process. So the topic is about some conflicts about land use and access rights between people who are growing rice and also some other ethnic groups that are mainly herders and raising cattle. And there are some strong conflicts in the use of the land in this region. So as I already mentioned, my colleague Patrick Daquino was working on a pilot project on land use planning. And here you have some elements on the institutional context. So they were working collectively with tools like GIS, and they were also collecting data in the field and having a lot of participatory activities prior to the use of the role-playing game and the agent-based model. At some stage, we decided to test this methodology precisely with the goal, the objective to try to tackle difficulties in discussing conflict issues among participants. So the specific objectives of this experiment, that is called self-CORMAS, was to provide local authority and farmer organizations knowledge and capacity to take initiatives, and also to be in a position to make proposals, and to help local populations to understand, monitor, control, management rules. Really, it was with the idea to increase the possibility of local people to participate and to participate to an empowerment process. So I come to the methodological aspects. It's, as I mentioned in the self-CORMAS experiment, the use of the models, role-playing games and agent-based simulation is rather short in time. We had 3 days workshops in 3 villages. So we had 3 times these 3-day workshops. As you can see, it's quite short. From the first day, we spent the day identifying and characterizing resources and space, local space around the village, and discussing satisfaction for every type of use with local participants, the farmers, discussing about the rules and behaviors, and also working together on a simplified spatial representation. On game 2, we had role-playing game, Threat. The role-playing game was not designed in advance, but based on the results of the first day, we just designed the role-playing game by playing it during the second day. And on the last day, we came with a simulation tool that was designed on the fly based on what happened in day 2 during the role-playing game session. So day 1, we used tools like participatory GIS that had been used before by Patrick during the process before, during the preliminary stage. So we used this tool to design a simplified representation of the space. As you can see in the picture on the left side here, based on the GIS tools, we had a very schematic representation of the space around the village. And it served as a game board. And from this schematic map of the village, we invited each of the participants to come and to stick some elements on the board directly to represent the activities to be performed by each of the participants. And we designed the rules of the game by playing it, basically. Here you have also an example of, we made a grid. So, and on the fly, we decided like, okay, if there is already one post-it in one of the cell of the grid, so you have to find another place and so on. So that was the way to define the rule by playing it. We had 10 steps representing 10 mounts to play it. And then we had also discussion on the indicators to be used to discuss about the problems, inconsistencies, deadlocks, conflicts that experienced during the game. And we also started to discuss about possible scenarios to go a bit further and to try to overcome these problems we encountered during the game. So we started to identify scenarios. From day 2 to day 3, we had a short time to prepare the simulation tool, but the idea was, as you can see very clearly, the agent-based model is very a toy model. And we defined the behavioral rules for autonomous computer agents based on the previous rules. And we had discussion to validate these rules by the participants. For instance, for a farmer in the computer model, what are the criteria to be taken into account to decide what to do during the rainy seasons? It's related to a kind of soil. During the dry seasons, it's related to a distance to permanent water. And for the herder, you have the similar kind of rules that were discussed collectively. And that were translated into the computer simulation model. We also used the GIS tool. It was already used to draw the game board with the participants during day 2. And we use it also to make it quite close to the tool onto the game board to have the environment of the agent-based model very similar to both the GIS and to the game board. And finally, the day 3, we came back with the agent-based simulation tool. And we used a design quite close to the design that was used during the role-playing game. And we discussed about scenarios. Here I have a basic simulation. One step is 1 month. So the simulation is run in front of the participants. And we look at what is happening for the basic scenario, for the basic simulation. And then we move to another scenario. For instance, we had the idea of maybe a solution could be to add some canals. Let's see what would happen if in the simulation we add some canals. So these are the blue lines you can see on the right side of the screen. So the same simulation with 10 time step with canals. What will happen? So we run the simulation. At the end of the simulation of this second scenario, we discuss again. It happened that there had some congestion of space along the canals. So the participants decided to test the scenario with access rules added to the infrastructure building of the canals. And again, we run the simulation in front of them with both the infrastructure, the canals, and some rules to access infrastructures. Okay, and finally, what happened? One effect of these workshops a few years later, we could see on the Google map these canals finally were designed on the field. So this was something for sure that was already in the mind of the people that were working in the development project in the region. But actually, it happened that in reality, some of the discussion we had during the workshops led to the realization of the building and some infrastructure on the field. Okay, I move to the second example because I found it interesting to show you another examples where the design, the co-design of the models, role-playing games and simulation agent-based model took a much longer time. So here in Thailand, the problem and research objective were linked to interactions between labor scarcity and migration of people and rain-fed lowland rice growing. And we wanted to better understand this interaction to mitigate the risk of failure of state investment in water infrastructures aiming at upgrading livelihood of local people. And we had this idea from the beginning to design agent-based simulation to work on that. But here, again, we had a preliminary phase to do an initial diagnosis with the objectives to better understand the key question to be examined, to become familiar with the key local informants, to select the study site and the participants, and also to start building an initial conceptual models. So we can see that using role-playing games is a kind of mixed methods. Maybe we can discuss again later about that. But there is a strong linkage between the preliminary stage and the start of designing role-playing games. For instance, we need to come out with a typology of farmers. And here we had a typology with 3 types of farmer, type A, B, C, you can see on the left side. It's quite important to select the right participants based on that preliminary stage, to have a selection of participants that will represent the diversity of the different ways to practice farming in the region. And the next slide, I'm not going to detail all the stages of the co-design of the role-playing games and agent-based model of this work. But as you can see, starting from the first role-playing game, we had a long process, more than 2 years, with a succession of role-playing games and the introduction of simulation tools, computer simulation tools, along the process of co-designing the simulation tools, with the specific objectives for each of the workshops we had, and progressive introduction of computer simulation tools. At some part of the process, we had computer-free role-playing games, and along the time, we introduced the computer simulation. Here you have example of a first role-playing game session at the beginning of the process, where we had cards and people interacting without looking at the computer screen. The computer was just used to compute the results of the players, but we had no agent-based simulation. In another session, we introduced the display of the computer simulation, and it was a kind of introduction to this kind of tool to the participants. We still had cards on board games, but also to discuss about the results of the game, we introduced a playing game simulation to the participants. And finally, we had all this process was used to co-design the structure of the agent-based model. And here you have a UML class diagram showing the main conceptual entities and their relation, and that finally was used to design the final version of the autonomous agent-based model. As you can see, it's quite simple, but still we have, for instance, different roles of the farmers. And we had also the different infrastructure in terms of water tank that has been designed to feed the model. Here you have a picture on the special interface of the final version of the agent-based model. As you can see, it's still a very abstract simulation tool in terms that we just have 2 representatives of the type A farmers, A1, A2, and 1 representative of type B farmer and 1 representative of type C farmer. And we have a kind of stylized representation of the landscape. It's not representing any kind of GIS-based portion of the landscape. We just have a representative of the type of farming. And we also have the representation of the climatic conditions. The time step of the model is a week. And we also have representation of the water levels in the pond of some of the farms. Not all farms have ponds, some of them have ponds, and we have representation of the water levels in the ponds. So how the role-playing game was useful to design the IBM? It was useful in terms of conceptual entities, it was useful in terms of the representation of the space, and also in terms of parameterization. For instance, here we have the different values to move from the dependent status of a farmer to in between 17 and 45 years old the farmer in the model can migrate. And if they are between 15 and 17 or between 45 and 65, they cannot migrate, but they can work on the farm. And if they are less than 15 or more than 65 years old, they are dependent. Okay, so this was discussed along the process with the participants and slowly introduced as rules of the games. And finally, we used those values as parameters of the agent-based model. Of course, we also had rules and behaviors as components of the agent-based model introduced in the computer tool and discussed during the role-playing game session. We used UML, Unified Modeling Language, directly with the participants of the role-playing game sessions, just to agree on some, you see here are some decision trees according to tests or conditions. You will navigate from the starting point, the black circle, to the ending point. You will navigate those branches according to results of some tests. All these conditions and different branches have been discussed also directly with the participants of the participatory workshops. And also, finally, we discussed about scenarios. And at the end of the day, with this ABM, we had part of the scenarios that were identified by the participants. We call them field-based simulations. And we did some participatory analysis of these scenarios. But also because we had, at the end of the long process, we had a version of the agent-based model that could be used in a more classical way to perform some extensive sensitivity analysis and to run and to explore different scenarios in a more systematic ways. So these are what we call here laboratory-based simulations analysis. Okay, and finally here I have just as a last slide an animation just to summarize a little bit the combination of these two tools, the agent-based simulation and the role-playing games. It was a quite long process in which we started from actually even before to go to the field and to initiate the process of designing role-playing game sessions with and playing role-playing game sessions with the local farmers. We went back and forth between the two kind of tools, the role-playing games that evolved along the process and served as the design tools to feed the computer, the autonomous computer agent-based simulation. And as you can see, this is a much longer process than what I explained in Senegal. We had 3 days workshop only, and here it was a 3 years process, quite different actually. Okay, I stop here my presentation and thank you for your attention.
Thank you very much, Christophe. So let's see, because we have several questions here. Bruce, you said that maybe you will want to group them, but shall we group them or do we just take them in order?
I think we just take them in order. They're not obviously repetitive.
Yes. Okay, then Christophe, do you have access to the chat?
Yes.
Yes, and if you scroll up, the first question is from Edmund Chateau-Brown. What does it mean, if I have understood correctly, that farmers and herders must agree the ABM rule for herders say? Does this mean they agree what herders ought to do or would admit to doing rather than what they do?
Try to. Is it on the chat also? Yeah,
yes, but you have to scroll up. It's at 1:24 p.m.
24. Okay. Okay. If I understood correctly, I have to maybe precise that actually most of the participants they practice both activities. They are not like it's not like you are either a farmer or a herder, but both of them practice both activities. But the truth is that some of them are more herders than farmers, according to their ethnic group. but all of them know the other activity a bit. So they have some knowledge about the other activity. But obviously, when we discuss about the rules for herders, the Pearl participants, the one who are herders in most, their main activity is cattle raising. They were more active in validating the rules related to cattle raising than the other kind of participants. I don't know if this is completely answering your questions, but I think it was important to precise that both participants practice this activity.
Edmund, did that answer your question?
Yeah, that's fine. Thank you.
Okay. Melania had a question. How did you keep track of how the agent-based models rules were formulated? How did you link what was said in the role-playing game with the rules you made in the ABM?
We draw diagrams, UML diagrams, like activity UML diagram, in a participatory way, meaning that it was kind of debriefing of the role-playing game sessions, or we had also very specific sessions not playing at all, but after having played the session before, coming back to what we thought were the criteria used by participants to decide during the role-playing game sessions. Mm-hmm. And as a kind of validation of our assumptions, we were drawing UML diagram, UML activity diagram with the participants.
Mm. Was there lots of discussion or an agreement about that, or?
Yeah, we had a lot of discussions. Yeah,
a lot of discussion. So not immediate agreement.
No.
No.
Well, it depends, but
that's the gray hair,
we had
right?
a lot of discussion. But also I have to say that we had 8 households belonging to type A, which is the most frequent. But we had only one household, 1 or 2, I think, for type B, and only 1, that's for sure, for type C. Mm-hmm. So when the algorithm is not the same for type A, B, and C, and when you have only one household in the room to tell you what should be the algorithm for type C, then it's easier to reach an agreement with only one household belonging to one type. But for algorithm for type A, for instance, with 8 households in the room, of course, it was a bit longer to reach an agreement.
Mm-hmm. Did that answer your question, Melania?
Yes. Thank you,
Okay.
Christophe.
Romina Martin asked, what kind of aggregate measurements were used to evaluate the simulations? How could participants make sense from those instead of the map, or did they?
To evaluate the scenarios, you mean?
Yes.
Outputs of the simulation.
Single runs that they were watching.
Yeah, okay. It's true that when we were running simulation with the participants in the room, we were only running one simulation. We were not doing the replication just to check the, let's say, the statistical validity of the outputs of the simulation. Mm-hmm.
Okay, even in one simulation, you might have aggregate measures that give you some overview on what happens on the map instead of just single cell movements or occupations and rule applications.
Yes, we had indicators, but we also showed some indicators and not just looking at the space interface. So we had some values of indicators. We did not very often use charts to show them these indicators, but more easily final values of indicators. And because we had these different types of stakeholders, we were comparing the values of the final values of key indicators, and just comparing to the previous run, and usually one run, one scenario. We just only had one run for each scenario and comparing the final values of key indicators.
Mm-hmm. Is that good, Romina?
Well, it didn't answer how much sense they could make from the indicators, but maybe this was just not part of the discussion.
Yeah, okay, I see what you mean by making sense of the indicators.
How they relate to them. Yeah, does it
Yeah.
have a meaning how much the production is of the more pastoralist people or of the more farming people, like how they distribute land or such?
Well, these indicators were the same than the one used during the role-playing game sessions. So during the debriefing of the role-playing game sessions, we had discussion on the, we had collective discussion on what kind of indicators are meaningful for them. And most of the time in the agent-based computer simulations, we provided the same indicators. We had additional indicators, but at least we had also the same sets of indicators that were used during the role-playing game sessions.
Thank you.
Okay, Vonda had a question. Are all modeled agents behaving individually, or is there social interaction? Is there social interaction going on as well in the game, I presume, right? In the model, I presume.
In the model.
Yes.
Yes, indeed. Because I can easily imagine that in the practical situation, there can be a conflict between your individual interest and the norm of how to behave in this system. So I was wondering if this is also being represented in the model, that you have a kind of norm going on, or for example, that they learn from each other in the model.
Yeah, that's a good point. But most of the time, no, we don't have this kind of refinement in the kind of agent-based model we provide to explore scenarios. We just leave all these aspects outside of the simulation.
And is this being discussed in the group meetings, the norms?
As far as I can remember, not very much, no.
Okay. We had a question from Sebastian. What is the reason for the first determining the individual elements of the game, characteristics like rules are first, and then building scenarios instead of doing it the other way around? First collecting knowledge about the phenomena you try to model by investigating scenarios. Maybe you can comment about that.
Yeah, it's true that most of the time we just try to represent situations in the modeling tools, the games or the computer simulation, that are familiar to the participants, because this is what is more or less happening right now. So it just we just start by representing situations that are easy to grasp by the participants, because this is not something that is not happening now. And we do that for having a first stage to introduce the modeling tools to the participants so that they become familiar with the tools. And then we move to a second stage where we can explore or first discuss about what could be changed or what could be tested, because for us a scenario is could be any kind of rules to be tested, or I don't know, a change in the external conditions, like a change in for instance, of the market price or climatic conditions, or any kind of differences to the standard conditions will be used as an element to define scenarios. And so we assume that it's easier for the participants to move on to change some aspects of the simulation after having discussed about what is happening regarding the current situation.
Sebastian, did that answer your question?
Yeah, maybe a little follow-up on what my attention behind that question was. I was wondering if there is a connection between the sequence you choose there and the actual purpose of the model, because it seems like if you do it this way around, there is a clear design purpose. And maybe if you do it the other way around, it's more on broader explaining what is happening there, because there might be some kind of, I want to be careful with this, but some kind of bias if you already collect the information which are going to build a model. You might miss some information or parts of the phenomenon which are maybe not as easy to model, and so they somehow go through your radar, basically. So that was my idea behind that.
No, it's true. I think it's very true. The main, the most important objective for us first is to get the participants engaged with the tools we provide. So to us, it's utmost importance to let them become familiar with the tools. And then later on, if we need to adjust the tools, because for instance, there is a limitation, we cannot address an issue that will come out during the first interactions or the first workshops, then it's possible that we need to refine the model or add something new to the model that we did not think about right from the beginning. But at least we try to engage the participants in becoming confident in using this kind of tools.
Thank you.
Xiao, sorry, I'm not very good at Chinese. We've covered some of your questions. Do you want to sort of pose a question to Christoph in a new form? You said you had 3 questions. How do you elicit rules? We talked a little bit about that. How do you select and assign some rules to the agents? And then how do you evaluate the outcome of the model? Talked a little bit about that. Maybe, Christoph, you talk about how do you assign some rules to which agents? Or
there is a most of the time the conceptual model is strictly equivalent between the role-playing game and the agent-based simulation model. So the rules applied to an agent are the rules that we discussed during the debriefing of the role-playing game sessions, because we just translate. I mean, there is a direct matching between a role endorsed by a participant during the role-playing game session and a type of agents in the computer simulation model.
Did that
the linkage is quite strong actually between a kind of role in the session and a type of agent in the simulation.
Did that answer your question? Come back. Yeah.
Yeah. So I think I feel like for different participants, they have a different opinions, but then how you specially distribute them on your simulation world, the map, it will affect how they respond to reality. So I just feel when you are in a workshop, to know their opinion, when you assign them to your simulation world, the model itself, how the assignment will affect the output itself. So for example, if you have a workshop, you have 3 opinions, but these 3 opinions, it really, I think it will matter how the farmers or the hunter or the rangers display on the map. So like, do you have any special rule when you assign their opinions into your agent? And then that will affect your baseline. Like, how do you evaluate your baseline's real, like close to reality?
Yeah. If I understand exactly what you mean, you are talking about, for instance, if we have a population of agents, how do we distribute the possible behavior to our population of agents? And of course, this has a strong effect on the results of the simulation. If we just run a simulation with the whole population of one type of agents behaving in the same way, and compared to all the different combinations of having more heterogeneous behavior among the population of agents. So for instance, with the role-playing game sessions, we can just get an idea of the frequency of each kind of behavior, but it can happen that one participant will behave in a very specific way, where most of the other participants would behave in a more standard way. So we can just say, okay, look, we just need here to get a standard behavior. So it seems that this behavior is more frequently performed by the participants of the role-playing game. So for the computer model, we will have this behavior as a standard behavior. Usually we do like that, but then with the computer model, you can investigate the effects of the different distribution of possible behaviors among your population of agents. It is more related to, let's say, a systematic exploration of your computer models that you can perform in the lab, not necessarily during the workshop with the participants, to make sure how to assess the sensitivity of the result of your models to this particular aspect of distribution of behaviors among a population of agents.
Okay. I want to go down to Yuan's question next, because otherwise it's mostly us normal suspects. You explained that the importance of the preliminary phrase that was critical for the model, in which some of the frameworks for the model are put down. How is this recorded and registered and then translated into the model? In this line of thought, it might be that cultural and social norms are left out of the model because they're not in that stage. So what is the importance? Can you just describe more about the importance and impact of that preliminary stage?
It's yeah. It's important by many aspects, but I think that for the selection of participants to your workshops, if you want to have a representative, not only representative participants in your participatory workshops, that's one aspect, the representativeness. For instance, based on surveys and interviews, you produce a typology of farmers, because most of the time we are working with farmers. So to get this typology is quite important, because a limitation of a kind of limitation of role-playing game sessions, for instance, it's very difficult to have a huge audience to these workshops. You can do a good job with between 12 and 20 participants, but if you have more than that, it's quite tricky to manage. And so due to this limitation in the number of participants, you have to select. And when you select, you still have to get representative of the main type of actors to be part of the workshops. That being said, sometimes the preliminary stage also provides you some information about power relations among the stakeholders, so that you will not anyway invite straight from the beginning the different type of stakeholders, like managers together with farmers, for instance, because you know that it's quite sensitive. You have some issues to invite the people at the same workshop. So you would decide based on the information of the initial diagnosis, would separate with different groups and have different branches in your process, participatory process, with from the beginning participants with only farmers, participants of other workshops with other kind of stakeholders, and only at the end of the process, or maybe not at the end, but not at the beginning for sure, you can imagine that you can organize workshops with different kind of participants all together in the same room. So I mean also to get some information about these power relations, the initial phase is quite important.
Mm-hmm. Did that answer your question?
Aspects, representativeness, and also to take into account power relations or power asymmetry, or I don't know exactly how to say it, but these two aspects are crucial, and you can only get them from an initial phase, a preliminary phase of your process.
Can I have a short?
Please, yes.
So thanks for the answer, and but then my question is, how do we record that then? Because this is happening, and this is part of the qualitative experience. But when you just at the end just show a model, then you lost all the qualitative, concept of it. And just how do you record that in your research, or it's not necessary to record that? Like how do you use that empirical material in the process? Record it, yeah.
Yes, so you describe it as part of the participatory process. So of course, this is not embedded within the modeling tools. It's like we started to discuss, we are not going to internalize these aspects into the modeling tools, but we are taking this into consideration in organizing the process. And this is something that we will relate in describing the whole participatory process as part of the way we conducted the process.
Okay,
so
we're going to have
when we describe this kind of participatory processes, the description of the model is one thing, but it's not the main thing. The main thing is really to relate about all this way to manage the participatory process.
Mm-hmm. Mm-hmm. Okay, we're going to have 3 more questions only, because otherwise we will run out of time. Harko wanted to know about the balance between sort of schematic rules representing all farmers, and if you're having individual rules for each farmer. Farmer 1 does something slightly different from farmer 2. To what extent do you generalize?
Yeah. I don't have an answer that could fit for any situations, but it makes me think about one option that we used in some of the processes, which is a hybrid simulation, where you have a population of agents and you can decide to go for autonomous agents for the whole population with no exception. And so in that situation, you have to precise what is the distribution of behavior for the whole population, as we discussed before. But one option is to take the control of, for instance, only one out of all the agents, and to keep this one, so you can specify exactly what you want in terms of behavior, and you can also have it interactively input during the simulation. So, and we have some models like this, where it's an option when you initialize your simulation to go for fully autonomous, or to just take control of 1 or 2 agents. And for these 2 particular agents, you open the floor for discussing how they would behave differently. Or you can also maybe plug them to a different, you can discuss about how should they behave. And if you have an algorithm to plug, okay, you decide interactively the behavior of 1 or 2 specific agents out of the whole population of agents. So I think this technical possibility to perform hybrid simulation in terms of taking the control of one of the agents and leaving all the other autonomous, it's an interesting option that we can use. Precisely also to discuss collectively about what does it change if one of the agents is not behaving exactly in the same way than all the other ones.
Did that answer your question, Harko?
Yeah.
Yeah. Okay, right, thank you. Martin asked, what are the decisive differences between the 2 examples? How, that you described a difference in approach, but what was the difference in effect?
in effect.
Yeah. Did one go much smoother? Did you get one was much more informative?
I think the first one of the effects it produced, by the end of the process, the participants, for instance, in one of the village, we did it in 3 villages. The kind of effects you can expect is like, okay, now we would like to, the participants in one of the village, they requested the organizers of the workshop to provide them a training on infrastructure for cattle raising, for a pastoral infrastructure. So they wanted to know more about what this infrastructure could bring, could benefit to them. And so they just collectively engage in a new action, but they did not reach any agreement or decided to change the rules of managing the system. But they, let's say, they just committed to continue to interact together. And with one ideas that came out from the participatory workshop. So I would say it's just an effect of stimulating the willingness to continue the collaboration.
Mm-hmm.
This is the kind of effect you can expect from a quite short process in which you use the simulation tools like in Senegal. In Thailand, which is a much longer process, we observed an interesting effect at the end of this process. It was the organization of a seminar in the local university where the local farmers went to deliver or to give the seminar to the scholars at the local universities. And they were using the simulation tools, like they had really the sense of ownership of the simulation model, because we worked together for 3 years on developing this agent-based model. And by the end, they were quite comfortable to comment, and to present, and to discuss scenarios, indicators, and difficulties also for them to perform their activities in front of scholars at the local university. So it was quite nice to see that they were comfortable to use the model as a communication tool, which is you can just maybe reach only if you allocate enough time for them to feel this kind of ownership of the model.
Okay, we have a question from Nanda Widjums. Linking the integration framework by me, how do you reflect on what you integrated? Reflecting on the process, what integration, for example, outside versus inside the model for you? I think she's just asking you to reflect on the integration process. How much was integrated there?
Not easy.
Haha.
The most you go into an autonomous tool, the most you have to integrate. So when it's tricky to integrate, by leaving it possible to interact with the simulation, as I mentioned with a hybrid simulation, for instance, if you don't know exactly how to integrate some aspects, you can leave like interaction. And then you don't integrate what will happen during the time. People will discuss about how should we decide for what to input in the simulation. This is not integrated into the model because you leave it as, okay, now we discuss about it. Including you can still have people arguing about, oh, but if you propose to input this way into the simulation, it's because you have some values in your mind, or if you are thinking that this is better than other ways to do. And then you can still observe how people will argue or discuss, reaching or not an agreement to decide what to input in the model. So when it's tricky, one way to to continue to work without integrating into the simulation model is to do it interactively. I don't know if this is completely answering your question. I'm just escaping a bit from
I think there are no clear answers to this question. I think it's just a deepening of the reflection, because I think a lot of the integration that happens in this project happens together, which is very different from often when models are made, that one modeler is making sense of things and integrates data or information into a rule. And this is a very collaborative process in which then decisions are made for what to include and how a rule, for instance, looks like. But then there's another point made by Bruce about, okay, well, and then you have the model. And when we press go, there is something happening as well in terms of integration. And I find it always a bit hard to put my finger on what that then is. And I was just trying to poke with you to see also what you think, what happens after everyone is done integrating together. What does the model contribute to bringing together in terms of knowledge to this whole process?
Okay. Edmund has one last question. Do technical issues feed into the model? i.e., what happens if, for example, what happens if herders and farmers plan to act in a way that experts would expect a bad outcome? Do you want to expand upon that, Edmund?
Yes, I just wasn't sure whether the model was entirely subjective, in the sense that you model exactly what the farmers and herders agree to. You don't ask the question, well, what they agree to, could that actually be bad for the environment according to some scientific standard? Or maybe that isn't your objective in building the model, to understand that dimension of things.
In the two examples I presented, that was not the case, but in other situations, we can face this kind of dilemma. In the two examples I have presented, the two models are 100% subjective in the sense that only inputs from what the participants told us. And there is no kind of scientific knowledge integrated into these two models. It's purely to represent the way the participants envision the functioning of the system. But we have other examples where we come with this kind of tricky problems where how do we balance the introduction of scientific knowledge? Most of the time, we just present this scientific knowledge as another kind of subjective knowledge, but still, it's us with our knowledge that would bring something into the models and not the participants themselves. Sometimes we just negotiate in a way with them because they don't have the knowledge, or they just agree to bring our knowledge into the model. But it's always a discussion between them and us related to the particular process we would like to have in the model.
Thank you.
Thank you very much, Christophe. We went over our time with the questions, but there were so many questions to you, and we just thought that it's good to use your experience and the fact that you are here today with us